Sir, actually, this lockdown has made us to learn a lot of new things like social distancing, uh, uh, how to be away from people. Because only we stand united for every good thing.
தமிழ் இங்கிலீஷ் அப்படி மிக்ஸ் பண்ணி பேசலாம் சுரேஷ்.
அப்படியா சார்?
Thank you.
சார் சின்ன இது வீடியோலாம் இங்கே ரைட்டில் வருது, அதெல்லாம் மினிமைஸ் பண்ணுது சார். அது எனக்கு என்னோட ஸ்லைட் அப்டேட் பண்ணுது சார்.
அதெல்லாம் பண்ணிடுவாங்க. இவரு கலை வந்து கம்ப்ளீட்டா அந்த வீடியோ எல்லாம் கட் பண்ணிட்டு வர உங்களுக்கு அஃபெக்ட் ஆகாது.
இல்ல சார், எனக்கு நீங்க பேசுறது, நீங்க அந்த வீடியோ நம்ம வீடியோஸ்லாம் சைட்ல தெரியுது, நம்ம பேசலாம். அதனால எனக்கு இந்த என்னோட ஸ்லைட் ஷோ வந்து பாதி மறைக்குது கால்வாசி.
இப்போ இருக்காது, இப்போ வந்து ஃபுல்லா கட் பண்ணிட்டாரு.
கட் பண்ணிட்டாரு சார்? இல்ல எனக்கு தெரியுது, என் பேச தெரியுது, நீங்க சொல்லலாம் தெரியுது.
உங்க வியூ சுரேஷ் உங்க சைடுல வந்து அந்த அந்த இதை பிடிச்சி இழுத்தீங்கன்னா நகலும், அந்த பவர் பாயிண்ட் அட்ஜஸ்ட் பண்ணீங்கன்னா நகலும். அப்படி இழுத்து பாருங்க.
நீங்க பவர் பாயிண்ட் இழுத்துங்கல்ல ரைட் ஹேண்ட் சைடு. இல்ல நீங்க வந்து இந்த இதை க்ளோஸ் பண்ணணும் முதல்ல.
ரைட் சைடுல ஒரு மார்க் இருக்கு பாருங்க, அதை பிடிச்சீங்கன்னா இந்த வேர்ட்
இப்போ ஓகே சார். ஷால் வி கோ?
இட்ஸ் ஓகே நவ.
குட்.
எல்லாம் மியூட் பண்ணிட்டோம். டோன்ட் வரி. எஸ்.
Shall we start, sir?
Yeah,
please.
So it's wonderful that we all are here today morning to really know what is hybrid technology, because every human being in this world has been so fascinated towards automobiles. Generally, we all use any one type of automobile or more times every day for our mobility, to move from one place to another. And there were also times when there was no mobility in this world, in this universe, and people would have really would have started like how to move goods and everything. But we are all very much blessed that the engineering and technology has invented a lot of new things for us. That's the way we all are moving goods and people nowadays. So before getting more into hybrid technology, let me give you a small insight on what is hybrid first of all. So hybrid is something that is a mixture of two very different things. So it may be a vehicle with an engine that uses a petrol or a diesel engine and a type of another source called electricity.
கொஞ்சம் மைக் க்ளோஸா வந்து பேசுங்க.
கேக்குதா சார்?
ஆமா, கொஞ்சம் ஆடிபிலிட்டி கொஞ்சம். எஸ்.
இப்போ சார்? இப்போ கேக்குதா சார்?
Yeah, now it's okay.
Okay?
Okay, yeah.
Thank you. So on a bicycle that maybe it uses two different types of bicycles with very different features, so that the hybrid bicycle will have a different range of working condition. And researchers began developing hybrid agriculture crops to maximize efficiency. Mainly, we all have heard a lot of things about hybrids. Like we see hybrid fruits, we see hybrid vegetables, we see hybrid machines. But many of our grandparents, they generally used to say, ஏன்பா அந்த ஹைபிரிட் பொருள்லாம் வாங்குறீங்க, ஹைபிரிட்னா புதுசுப்பா, அது வந்து என்ன செஞ்சிருப்பாங்க, எப்படி செஞ்சிருப்பாங்க தெரியாது, ரெகுலரா கண்ட்ரி ஃப்ரூட்ஸ் கண்ட்ரி வெஜிடபிள்ஸ் வாங்கி சாப்பிடுங்க அப்படின்னு நம்ம நிறைய பேர் சொல்றது கேள்விப்பட்டிருக்கோம். பட் ஆல்வேஸ் ஹைபிரிட்ஸ் generally invent new things, brings new things to us. So that is how hybrid vehicles, how it reduces pollution levels and how it improves performance. That's what we are going to look at today. And hybrid is also anything that is a mixture of two or more things. And we generally call, just to say that bird is also a hybrid of a goose and a swan. We all come across two different terminologies. One is technology and another one is engineering. And we always misunderstand both these terminologies to really make the other person who is talking to us, make him also to really realize what is technology, what is engineering. So many people say that I study engineering, I study technology, I study BTech, I study BE. But when you're going to ask them what is engineering, what is technology, always there will be a kind of thinking like, what's the real definition of technology, what is real about engineering? Is real technology big or really engineering is big, or which one is better, which one is superior? So let's see what is technology about. While engineering is specific to a certain task and technology maybe it applies to a larger area. So engineering and technology are two terms that are very closely related, but very oftenly we mistake both these terms in different places with one another. So engineering can be defined as the profession in which a knowledge of the mathematical and natural sciences gained by study, experience, and practice is applied with judgment. Whereas technology can be defined as a branch of knowledge that deals with the creation and use of technical means and their interrelation with the life, society, and environment. And moreover, there's another way of looking at engineering and technology, which we generally call engineering can be taken as a question or a problem, whereas technology can be looked at as a solution to any questions. So there are different kinds of technology, like as we say, hybrid cars, there are hybrid rocks, hybrid systems, hybrid tea, hybrid vegetable, as I said, hybrid plants, hybrid vigor. There's a hell a lot of things beyond technology, beyond hybrid. But how these hybrid vehicles are segmented? There are 4 different means. Let us see what is that. First, it is segmented by the type of the hybrid vehicle, which is actually micro hybrid, mild hybrid, full hybrid, and fourth one we call it plug-in hybrid. And the second way we segment is by the vehicle range. Maybe vehicles which runs from 20 to 50 miles, and vehicles which go up to 100 miles, and vehicles which go beyond 100 miles. This is how the vehicle ranges are segmented. And the third way of segmentation is vehicle type, whether it's a passenger car or it's a commercial vehicle. Nowadays, we are seeing a lot of commercial, passenger cars into hybrid electric vehicles as well as electric vehicles. But days are not very far off that most of the commercial vehicles are also going to be electric and hybrid electric vehicles. The fourth kind of segmentation is the geography. What kind of geography does this hybrid vehicle dominate in the world? If you look at this, you can see the vehicle growth of the hybrid vehicle market across the globe. It is highly dominating in the Chinese market, in the American market. And if you look at India, look at Australia, some of the United Arab Emirates, you can see there it's a bit lesser when compared to the Chinese and the American market. And it's a bit low in the African and the South American area. But these are not, as we are discussing, every engineering industry is working towards how to bring in a lot of electrical technologies in terms of hybrids as well as electric vehicles to make sure that we pollute the environment very less and also have a good performance on our vehicles. You can see the kind of electric vehicles on the US roads in the last 6 years. See how many multi-floors it has grown, and this is how it's going to grow in all the markets across the globe in the coming years. Maybe another century or another decade, we'll see the electric vehicles and hybrid electric vehicles dominating the IC engine market over engineering industries. And here you can see the kind of countries like China, Europe, United States, Norway, Germany, how it has been developing in the last 5-6 years. Everywhere there's increase, and nowhere there's even a slight down. So it clearly indicates that we are all moving towards electric cars and electric hybrid electric vehicles. These hybrid electric vehicles are actually the drivers behind the invention of these kind of vehicles are mainly the 4 important things. The main thing is the increased fuel economy, the stringent emission norms, because now we are marching towards BS6, and you would be knowing that how much ever we're going to contain the hydrocarbons, carbon monoxide, nitrous oxide, particulate matters which are emitting into the environment, how it is very adverse to the humankind, human future, the planet. All these are very important drivers for invention of these kind of electric vehicles. And as well, the falling battery prices, and more you're getting into electric, the batteries are costing less. And that's also one reason why we are using a lot of batteries in these hybrid electric vehicles and electric vehicles. And the low price compared to other electric cars. Generally, electric cars are a bit costlier because they don't have IC engines, whereas hybrid electric vehicles will have IC engines as well. So that's a bit comparatively lesser in cost when compared to electric vehicles. So you can see the market, the Europe market is growing a bit more, and you can see the 2017 how the market size was $57.2 billion US, whereas in 2020 it's going to gain to $138 billion. So all of us, every household, the future is going to be a hybrid electric vehicle, more than whether they're going to have IC vehicle or not, they'll be surely having electric vehicle. So before getting into vehicles, let us see the evolution of vehicles. Why these vehicles evolved? To think of the mankind like 2 centuries ago, like how people would have traveled, people would have carried their goods to move from one place to other. So that is how the invention of wheels improved our traveling time. It improved the load capacity. And those times, even before the invention of vehicles, the horse carriages were used for moving people. So even today, we all are very fond of moving by horse carriages. Whenever we go to our native places, go to our villages, still we see horse carriages, and all these were very much importantly used in those times to move people and goods. But slowly, as time passed, the invention of electricity, the invention of IC engines paved way to the automobiles. So that's how the vehicles evolved in the planet. So the vehicle, the hybrid electric vehicle is actually classified into 3 important power plants. First one is the electric motor, which is actually one of the prime source of power in any hybrid electric vehicle. And the second one is the internal combustion engine. So it's also another power source where in one case both are used as prime source of drive, whereas in another case either one of these are used as a prime source of drive. In hybrid electric vehicles, both these may be used. There are vehicles wherein only electric motors are used for electric vehicle, wherein only IC engines are used as a regular automobile, and combination of both these has emerged with hybrid electric vehicles. So let's see the internal combustion engine. So Mr. Carl Benz in Mannheim in 1885, dating a century back, he invented the first three-wheel car. But initially, the performance of these power plants was not that good enough, so that it was complemented with a DC motor with complementing with which is powered by small batteries. That's mainly because of the power density. Power density is nothing but the size of the power of the engine to the size of it actually. But actually, the continuous development industry led to the development of compact engines with high power figures that made them the most preferred automobiles on earth that was seen in the 20th century. And that's what is going to happen very quickly in the 21st century as well. So how the electric vehicle came in? So in 1881, Mr. Gustav Trow, he was the one who first introduced the electric vehicle, and he used a very low power DC motor with 0.1 HP, which was powered by lead acid battery. This is how he invented the first electric vehicle in the world. But the range and performance because of the electric motor made it very increasingly difficult to compete with IC engine, because IC engine we all generally believe that it's very powerful than a regular electric vehicle or a hybrid electric vehicle. But you can, the coming stage, you'll be seeing the world's most powerful cars are high-speed cars or hybrid electric vehicles. So there are big contradictory things which we will see, which will be seen, and also the lack of development in power electronics. Also, these things in the due course proved to be a very much downfall for the electric vehicle, as it was difficult to control the electric motor's power output. That's very important, because unless otherwise you have a good control over the electric motor, the power output will be varying and moving here and there. And however, the invention of regenerative braking in the year 1897 proved to be a significant contribution to the electric vehicle industry that is present today. So the regenerative braking is very important in any electric vehicle or a hybrid electric vehicle, because the energy what we generate has to be stored. So if you're not going to store the energy which you're going to generate, it's actually a waste of energy. So you can see there's a comparison of speed versus torque and power characteristics with regards to an electric motor as well as a gasoline engine, which really makes that the electric vehicles are close to ideal power plants in terms of torque and power boost. So hybrid vehicles are kind of vehicles which are going to use two kind of power sources, the primary and the secondary, such as an IC engine and a fuel cell or an electric motor and flywheel. So the first hybrid vehicle was presented in 1899 in the world. So a hybrid car is one that uses more than one means of propulsion. So as we told you, it might be an electric engine or an electric motor and a gasoline engine. So that the main advantage of hybrid car is that it should consume less fuel and it emits less carbon dioxide than a comparable conventional petrol or diesel engine vehicle. because as we are working from Euro 0 norms to Euro 1, 2, 3, and then now Euro 6, we all at automobile industries work very hard, really tiring that how to make our engines work for Euro 6 norms. So that is where we all work, because from Euro 4 to Euro 6, when you are going to move, there's a very stringent control on the emissions by over 60 to 80%. The amount of carbon monoxide, the amount of carbon dioxide, the amount of hydrocarbons, the amount of nitrous oxide, the amount of particulate matter. The more and more it's getting stringent as years to come. Now we are at BS6. The more when we even grow up and go beyond this, it's really very hard to work with IC engines. That is why these kind of electric vehicles are going to support us in making this planet more greener. So these are the three fastest cars on earth: the McLaren P1, the Porsche 918, and the Ferrari cars. And these three cars are, we generally call it as the Holy Trinity. So all these three fastest cars, well, generally people believe that the fastest car may be an IC engine vehicle, but the hybrid vehicles are the fastest car on earth, and these cars are all hybrid vehicles. So in hybrid technology, the IC engine exhaust gas actually, in any IC vehicle, we use a term called electric converter, catalytic converter. But why there was a need for hybrid technology? What did people know, made people to really think why we should move to hybrid technology, kind of different technology from IC engines? That's mainly because of the exhaust gases, what we let inside the environment. Like actually, as we told, the amount of unburned hydrocarbons, nitrous oxide, all these are affecting humans. However, the use of catalytic converters in the exhaust system is actually a kind of converter, which is a kind of component which is fitted to the exhaust system. And these converters got metals, namely platinum and rhodium, which converts the harmful gases into less harmful compounds like carbon monoxide to carbon dioxide and unburned hydrocarbons to water and carbon dioxide. The conversion happens in this catalytic converter, and mainly these converters reduce pollution and actually lowers the vehicle's mileage, and it's also more expensive. So the use of catalytic converters in the exhaust system requires very high optimum, require very high temperature for operation and for optimum performance. So generally, when we start vehicle in the morning, say we start cold start, we state a cold start. So the vehicle undergoes a very high kind of power and generates the maximum emission of hydrocarbons when we start the vehicle early in the morning. So we have to contain all this. So the Euro 5 or the B6 norms involves use of larger amount of platinum in the catalytic converter to bring the emissions down, which in turn increases the cost of vehicle as well. So why there was a need for hybrid vehicles? So the dependence of electric motors alone in vehicles results in minimum pollution, but increases the overall weight of the vehicle. And if you have to operate in various, require sufficient range, and also the handling becomes difficult. The cost per kilometer is very low, and so in the range as well. Thus, IC engine is preferred as the power plant if one requires to travel a longer distance, and the EVs, the electric vehicles, are preferred by those people who are traveling shorter distance within cities that require cost-effective performance in urban commutes. So let's see some of the common hybrid vehicles in the market. The BMW i8, where some of you would have seen on television, the kind of Toyota price where we these kind of vehicles on Chennai roads even. And Toyota markets this vehicle across the globe, and this is one of the products of Toyota, which is a hot selling cake for them across the globe. And you can see the Racing Point Mercedes F1 car. It's also a hybrid vehicle. And you can also see a moped there. And how the hybrid vehicles are classified is actually 5 times. We call it plug-in hybrid electric vehicles, mild parallel hybrid. The third one is the parallel hybrid. The fourth one is the series parallel hybrid. The fifth one is the series hybrid. Now let's see how this hybrid vehicle generally works. And before that, let's see the components of the hybrid vehicle. We got 6 different components. The major components in a hybrid vehicle: the electric drive motor, the auxiliary power unit. The third one is the generator. The fourth one is the energy storage system, because whatever energy we're going to generate, we have to store those. And so this energy storage system is one of the very important prime component of a hybrid vehicle, the regenerative braking system. the last but not the least, the control system. So the electric motors, that's where the electric vehicles will have only electric motors, whereas in hybrid vehicles, electric motors be the prime source of energy. So they act as the prime energy source that helps in transferring power to the wheel. So based on the drivetrain, the primary source could also vary between two available powertrains. So in electric hybrid vehicles, you will have electric motors, which is also a prime source of energy or a drive, and you will have the IC engine as well. So the drivetrain design, the gearbox design, based on that only the primary source could also vary between both of these, either a electric motor or a IC engine. An inverter along with an induction motor is the preferred electric motor for high efficiency in automobiles. Next comes the auxiliary power unit. It is actually mostly used in aircraft for safety reasons, and this acts as a backup for the primary energy source in certain conditions. So the auxiliary power unit is the prime source that powers anything apart from the propulsion or the wheels. Generators is actually also an important component. It's actually a computer, or the IC powers the battery to the generator. So you have the IC engine on the left side, and you have the batteries at the extreme end, and you have the generators in between. So the the engine powers the battery through the generator, which is located in between. And the job of this generator is to convert the rotational energy from the engine, IC engine, into electrical energy, which is used to charge the batteries, the power. So the control unit takes the decision appropriately. So what to use and when to use. And now comes the energy storage system. Generally, batteries such as lithium-ion are preferred over lead-acid batteries because of its reusability, because of its recycling capacity, because of its less toxic nature. These batteries are used as energy storage systems. So the research in the energy density of such batteries plays a bigger role on the size and the capacity of the battery pack. So the future of such electric vehicles depends on the improvement what we do in the energy storage systems in the power densities of such energy battery pack. So the very important term is the regenerative braking. So that's actually a very important component. So the ability of the electric vehicles to convert the kinetic energy into chemical energy instead of heat is called regenerative braking. Generally, this technology works in such a way that whenever the accelerator pedal is released, the vehicles brake automatically because of the energy conversion. And this also very much helps in less wear and tear in the existing braking. Because in the regular IC engine vehicle, when we do the braking, it may not be appropriate for everybody to apply brakes in the correct requirement. Whereas many people apply certain brakes may not be using appropriately. So there will be high wear and tear. Whereas in this kind of vehicles, this regenerative braking also helps in less wear and tear because of the automatic braking. In Formula 1 cars, there's a term called kinetic energy recovery system. And this system is used in much advanced version of Formula cars. So let's see how this regenerative braking works.
Regenerative braking is the recovery of kinetic energy during braking. In a conventional vehicle, a majority of the kinetic energy is converted during friction braking into heat and emitted unused into the environment. Hybrid and electric vehicles can use the electric motor to recuperate at least a portion of the kinetic energy for reuse. When the driver steps on the brake, the vehicle's electric motor switches to generator mode. The wheels transfer the kinetic energy via the drivetrain to the generator. Through its rotation, the generator converts a portion of the kinetic energy into electrical energy. This energy is stored in a high-voltage battery. The generative braking torque of the electric motor, which is the result of energy generation, decelerates the vehicle. At low speeds, for example, shortly before the vehicle comes to a stop, the electric motor can no longer supply sufficient generative braking torque and the friction brake must be activated. To maintain the required deceleration, the braking torque from the friction brake is continuously adapted to the current generative braking torque, a process called torque blending. In the case of full braking or an unstable driving condition, the vehicle is usually decelerated solely via the friction brake, as wheel-specific interventions are required. Regenerative braking enables an extended range in electric vehicles, as well as lowering fuel consumption and improving CO2 balance in hybrid vehicles.
Bosh. Excuse me, though, just hold on for a minute. So that's about regenerative braking. So next comes the control unit. As I said, the control unit is actually a computer or the collection of computers, including your engine control unit. And the responsibility of this is for efficient usage of available resources in a hybrid electric vehicle. So the control unit performs a lot of calculations based on the sensor inputs, because in the latest vehicles, a lot of sensors placed which goes beyond 1,000 and 2,000 and up to 1,000 times a second. These control units have to work, and they have to take several decisions every millisecond. So the state of the batteries, the requirement of the charging systems, the driver's input, so all are sensed every millisecond, thus ensuring optimum performance. So you can see some of the features that are not exclusive to hybrid vehicles but are commonly found in them. So the use of the Atkinson cycles to improve fuel economy. Whereas in a regular engine, the intake valve in the engine stays closed when the piston moves up on its compression stroke, creating pressure in the cylinder. But in Atkinson cycle, the valve stays open for a slightly longer duration. And some of the features is shutting down engine while coasting, and improved aerodynamics to provide less drag and better handling, using low rolling resistance tires, and powering the AC, powering steering systems, the other auxiliary pumps, electrically when needed, and small internal combustion engines also has evolved. So let's get into what are the different types of hybrid powertrains. One is the series hybrid, the second one is the parallel hybrid, the third one is the series parallel hybrid, and fourth one is complex hybrid. Let's see how these are working, how the working principles make this kind of vehicles more powerful, and how all these units are different from each other. Let's see how this hybrid vehicle works.
Let's talk about hybrid, also known as hybrid electric. These vehicles have been on the road in Canada for about a decade. Hybrids increase the efficiency and lower CO2 emissions, therefore greenhouse gas emissions. In other words, hybrids use both fuel and electricity. Both internal combustion and electric motors drive
Suresh, audio konja increase pannunga, audio.
Full இருக்கேதா?
idea.
அவருக்கு பட் சரியா வரலையே.
நீ கேக்குதா?
These two types of
நீங்க பேசுறது கேக்குது, பட் அந்த இதுல வீடியோல வர ஆடியோ கேட்கல.
internal combustion.
Okay. Yeah, good.
Provide motive power and to help charge the batteries of the vehicle. Second, one or more electric motors. These motors are located in different places in the vehicle, depending on the manufacturer. Both motors are connected to a transmission and out to the driven wheels. The third component is a battery, or series of batteries which store and send out electricity. Batteries in hybrid vehicles don't ever need to be plugged in because their charging needs are met by the management system of the vehicle, so they are never a draw on the electricity grid or your home electricity bill. Hybrid vehicle batteries generally last for the entire lifespan of the vehicle. Now, the way hybrids manage all of this technology is through a kind of mission control specialist, which is in fact a computer or series of computers. They make decisions about where power is coming from and where it's going. Thousands of times per second, they analyze the state of the charging system to figure out while you're driving along using steering, brakes, and accelerator, or listening to music from your mobile device. There's a lot going on. Here's a theoretical example of the kinds of decisions your car might make as you drive in different conditions. If you're driving along at 20 kilometers an hour, the car might ask the battery if there's enough power on hand for the electric motor to be your motive power. If the answer is yes, the internal combustion engine turns off. You are now running on electric power, depleting the battery resources. If the battery resources get too low, the engine comes back on to power the vehicle and to recharge the battery. If you encounter a hill or need to accelerate quickly and go at a high rate of speed, the system may allow both internal combustion and electric motors to give you the speed and power you need. When you coast, your engine shuts off, saving more fuel. And whenever you brake, power goes back to the batteries. That's called regenerative braking. Energy from the rotation of your wheels while you brake works like a power station, feeding the battery so it can store the charge for future use. And when you come to a full stop, the system turns off your engine, saving even more fuel. All systems and accessories continue to function. Lots of technology, all working in harmony, all very reliable. By the way, hybrids also use a number of other design features and technologies to run at peak efficiency, including a highly aerodynamic, low-drag shape, weight savings, and a much smaller and lighter internal combustion engine. Hybrids are like having the best of both worlds. On-demand power, significant fuel savings and lowered emissions, and smooth, quiet, emission-free electric motive power as well. So, if you are looking to improve the fuel efficiency of your vehicle, want to lower your CO2 emissions, and if you want to lower the fuel costs of your vehicle, consider a hybrid electric vehicle.
So that was the working principle of a hybrid vehicle. So let's see the first kind of hybrid vehicle. What we say is the series hybrid. So when the IC engine, like internal combustion engine, is to drive an electric generator, as I said earlier, to power the batteries rather than the wheels, this technology we term as hybrid or series hybrid tech. So electric motor is the primary source in this kind of a series hybrid vehicle, and it's ideal for stop and go driving. So these hybrid vehicles are most similar to the battery electric vehicles, what you generally see. And BMW i3, the car uses a range extender in its Sparkland as an option to change the battery, to charge the battery as well. So you can see the layout of this series hybrid electric vehicle, whereas you can see the electrical linkage, hydraulic linkage, and the mechanical linkage. And electric motor is the only one which is connected to the transmission here, whereas the IC engine can power the batteries, and the electric motor drives connected to the transmission. So here you have only a single kind of a linkage to the transmission, whereas IC engine is fully isolated to the transmission. It's not connected there. So what are the advantages of this series hybrid? So in the narrow RPM ranges, these kind of engines, IC engines can work even as the car changes speed. And series hybrids are relatively the most efficient stop and go city driving. More and more as the advantages are going for the series hybrid vehicles, we also have got some kind of disadvantages. So the power from the combustion engine has to run through both the generator and the electric motor. So during long distance highway driving, the total efficiency is inferior to the regular conventional transmission due to the several energy conversion. So then next comes the parallel hybrid. The earlier kind of vehicle where you saw only the electric motor is connected to the mechanical transmission, whereas in this parallel hybrid, you have a similar kind of a linkage from the IC engine to the mechanical transmission, as well as from the electric motor to the mechanical transmission. So a parallel hybrid is powered by an electric motor and an IC engine, both connected to the mechanical transmission. So both sources function as a prime source of power, and both these systems work in harmony to achieve optimum performance, to eliminate a turbo lag, and using regenerative braking to charge the battery. So the Model 1, the F1 cars use parallel hybrid technology as a power source. So here the layout clearly says or clearly indicates that the IC engine as well as the electric motor is connected directly to the power transmission, the mechanical transmission. So the advantages of parallel hybrid are the efficiency is higher during cruising and long distance highway driving. with a larger flexibility to switch between electric as well as the ICE power. So electric motors can be designed for less power as compared to the series hybrid, and also rather advantages. There are also some disadvantages. Parallel hybrid vehicles, it's more complicated, and ICE engine doesn't operate in a narrow constant RPM. Wherein in the earlier case, series hybrid ICE can work in a narrow RPM, as we told you, and thus the efficiency drops at low rotation speed. The third kind of hybrid is a mild parallel hybrid, wherein here it uses a compact electric motor which is less than 20 kilowatts to provide auto start-stop functions, to provide extra power assist during acceleration, and to generate deceleration. Some of the vehicles which use this kind of mild parallel hybrid technology is the Honda Civic, Honda Accord, BMW 7 Series hybrids, Suzuki S-Cross. These vehicles very commonly use these kind of technology. So next comes the series parallel hybrid. Very commonly you can see these kind of technologies in the Toyota Prius, very commonly seen in India as well as in many parts of the globe. So the series parallel hybrid system uses an electric motor to drive the vehicle at low speed and the gasoline engine on the other side to power the vehicle on high speed. So the optimum speed can be selected by the controller. And the Toyota Prius, as I told you, was launched in 1997 using this technology, and it's actually a very big hit in the customer market, and it is still under production. Toyota says that the biggest seller in the hybrid vehicle market is the Prius model for them in the world, and it's considered to be an important turning point for them and for them as well as in the transport industry. You can see the series parallel hybrid layout wherein the ICE engine is also directly connected to the mechanical transmission. On the other hand, the electric motor is also connected to them, but you have a generator to power the batteries here. And you also have the power converter. So you can see the electrical, hydraulic and mechanical linkage and how they are placed in this series parallel hybrid. So the advantage of this, the maximum flexibility, it is more flexible to switch between electric and ICE. It is smaller, lighter, and more efficient compared to the complicated ICE design. And it does also got some disadvantages. It's very complicated, more expensive than the parallel hybrid. And the efficiency of the power train transmission is also a bit low. You can see a Toyota Auris car, a perfect example of this series parallel hybrid. Next comes a plug-in hybrid. This is one of the common cars where you see kind of a car which you can park on the roads and you can charge with the charging stations available on the pavements. It has increased the energy storage capacity through lithium-ion battery packs that helps in aiding the vehicle to be driven all electric mode, a distance depending on the battery size. A subtype of hybrid vehicles is the plug-in hybrid vehicles. And as the name suggests, it can be connected to a mains electricity supply at the end of the journey. And it has also got a speaker that mimics ICE to ensure that the pedestrians are aware that the car is being parked there for charging. And those seeking to avoid use of ICE during daily could use such kind of a technology. Wherein Leaf is actually a very victorious model of Nissan. And as I told you, it's one of the first plug-in cars which was introduced by Nissan in this technology. And the last but not the least, the complex hybrid. Very less vehicles in the world use this kind of technologies, and submarines are once they are very much into this technology. You can see the layout of this technology while seeing it a bit complicated. So they use several motors and thus making the architecture more complex. So the hybrid text in submarines, the submarine uses a parallel hybrid powertrain. So it uses a gasoline engine which runs on the water surface, and it uses batteries when it runs on the water interior, when it goes inside the water. So this is called underwater. So underwater it uses electric motors for submerged propulsion. So while looking at hybrid vehicles, we also spoke about hybrid fruits, hybrid plants, hybrid various hybrids. Hybrid trains are also very famous nowadays. A hybrid train is a locomotive rail car or train that uses an onboard rechargeable energy storage system, RESS we call it, which is placed between the power source and a diesel engine. The traction system connected to the wheels. So they are diesel electric hybrids and have the components of a series hybrid transmission except the storage battery. Generally on race we see electric engines, or sometimes you also see diesel engine, which is actually pulling the compartments. But these kind of hybrid techs use both this engine as well as the motor battery. So storage system is either traction between batteries or flywheels, and the high energy conservation is achieved because of the use of hybrid tech. So how about the vehicle emissions in hybrid electric vehicles? Because the IC engines have full of emissions, whereas electric engines have no emissions. But what about hybrid electric vehicle emissions? So the emissions today are getting lower than the recommended level with regards to the hybrid electric vehicles, which is set by the Environmental Protection Agency. And what they recommend is the passenger vehicle should be within 5.5 metric tons of carbon dioxide. Whereas we really know how much they work for. They even work for less, and the vehicles such as Civic, Insight, and a Toyota Prius, they only give only 4.1, 3.5, 3.5 metric tons of carbon dioxide respectively. And these are very popular vehicles. Thus, hybrid electric vehicles reduce smog emissions by 90% and carbon dioxide emissions by 50%. As we all believe, even hybrid electric vehicles use, they have emissions, but not that to the level of the IC engine. So let's see the batteries, because when you use batteries, people always think of how to dispose batteries, because the batteries are a kind of threats for the environment, for human mankind. So how to dispose batteries when you use electric vehicle or a hybrid electric vehicle? Let's see the toxicity levels of batteries. So the lithium-ion battery is less toxic compared to the lead-based starter batteries, mainly used in cars. However, the nickel metal hydride used in most hybrid cars is found to be equal to lead-acid batteries in terms of toxicity. So recycling, disposing of batteries becomes a bit tedious, and lithium-ion is the perfect battery, most preferred battery as well for hybrid electric vehicles because of its weight and resistance to memory effect. Because of the kind of requirement and government stringent emission norms, technology is moving from IC engine to hybrid vehicles and now to electric vehicles. But to market, to bring a kind of this new concept and make people really understand that how these vehicles are going to help people in their day-to-day life to getting a greener planet, not only for us but also for the future generations of mankind. So the automakers spend a lot of money, a huge amount of money in marketing these kind of vehicles, because it's not that easy, because even today the government of India has many shops, they have provided a lot of excise duty cut when you get a hybrid electric vehicle or an electric vehicle. I recently believe that there was a 30% cut. These cars or vehicles are pricing nearly 40 lakhs, 50 lakhs, 60 lakhs. But nobody is really interested to, because of the technology, why we need to go for to pay that much more. So the government is bringing a lot of stops to make sure that people move to this kind of technology to save the environment. So the industry has sold millions of hybrid vehicles till date with the manufacturers like Toyota, Honda, Ford, BMW being the top manufacturers here. And the sales percentage may look very meager, say 2.2 in USA, but considering the volume of the vehicles being sold every year and the increasing to what we shown in the earlier slides, it's steadily increasing, and days are not far of that. One day, everybody will be having and owning an electric vehicle, irrespective of their IC engines or IC part vehicles, what they want. So let's see some of the advantages of this hybrid technology vehicles. It offers better mileage, it offers low emissions compared to IC vehicles, the reliability is more because of dual powertrain, and the plug-in charging is not necessary, unlike electric vehicles, so it requires frequent charging. The incentives, as I told you, the tax exemptions is offered to hybrid owners, and it's also more optimized performance, and the regenerative braking and efficient start-stop performance is achieved because of regenerative braking, and there's efficient usage of batteries. So until the battery density is improved, hybrid tech should be better than EVs. So when you have a lot of advantages, we also have more disadvantages as well. So the cost of vehicle is more than IC engine vehicles. The weight is still significantly more than IC engine vehicles. Because when once I saw, or when I first saw this Toyota price, like maybe 7-8 years before, I used to even think like, why I should pay a lot of money when getting these vehicles when I get a normal vehicle at 10 lakh or 15 lakh rupees, when those cars were priced at 40 and 45 lakhs. And only days have passed, and we all are in a kind of environment where we have to really work towards protecting our environment from these kind of emissions, kind of a greener environment, a place for a better place to live, better place for our future mankind. So the complex designs and architecture, that's also one of the major disadvantages of hybrid tech. And safety in case of accidents due to presence of engine as well as battery packs. People generally kind of have a lot of doubts and a lot of batteries are empty, but during accidents, what will happen? Those are all some of the disadvantages of these hybrid vehicles. And many people have these things in their mind. Are these hybrid vehicles safe enough to drive on roads? So the following will disable during high voltage, say the airbag deployment, high voltage leak, removing battery in the negative say. And what happens when a hybrid vehicle is submerged in water? Usually we believe that when we put anything in water, shock, gives shock. There's no risk of electric shocks from touching the car's body or framework in or out when it's wet.
Unparalleled fuel efficiency and awesome driving performance with highly responsive handling. That's the innovative Toyota hybrid system. Our hybrid system keeps evolving through continuous design and development. When a Toyota hybrid vehicle stops, all units cease operation and there is no wasteful consumption of energy. When starting to drive, a compact, lightweight, high-performance motor is used for smooth, quiet propulsion. During low-load driving, the motor is operated via appropriate control of battery power by the power control unit, thus achieving superior fuel efficiency. Motor drive is further augmented by engine power for smooth acceleration, featuring a dynamic force engine. The combination of VVTIE for lightning-fast changes in valve timing and high-speed combustion technology produces a quiet startup and more output, all the time giving fantastic improvements in fuel efficiency. During engine startup, this technology momentarily boosts battery output for a seamless merging of motor and engine drive, creating controllable acceleration for perfect handling. For normal driving, a power split device divides engine power between driving and power generation by the generator. This innovative hybrid system makes EV driving possible at a wider range of speeds, allowing the engines to be stopped even at high speed. The result is even better fuel efficiency and quieter driving. When decelerating, the vehicle's wheels turn the motor and the generated power is collected in the battery for reuse. Toyota hybrid vehicles operate by combining motor drive and engine drive within an efficient revolution range. The engine is stopped whenever possible. What's more, energy that used to be wasted is now reused to achieve fearless fuel efficiency, outstanding environmental performance, and highly responsive handling. The innovative Toyota hybrid system flawlessly combines these two elements.
So, before seeing more on electric cars and hybrid vehicles, let me show you 2-3 important slides what Ashok Leyland is doing on electric vehicles. Because we are not into hybrid vehicles, but as you all know, we are the first one to introduce electric vehicles in the Indian market, and most of electric vehicles are on trials in various parts of India. And you also would be remembering Prime Minister Modi, who introduce all the 50 vehicles all the 50 vehicles of Ashok Leyland into the fleet of Gujarat Transport Corporation. So let's see what is the basic components. You can see the conceptual design of our passenger vehicle, the bus. You can see the battery space inside. This is how a common difference between the IC engine powered vehicle and the battery electric vehicle. What are the components being replaced? Like in place of engine, it is replaced by traction motor in an electric vehicle. Like in place of ECU, it's a controller here. In place of mechanical air compressor, it's a DC converter in electric vehicle. In place of alternator, it is again a converter. In place of mechanical power steering, it's E-power steering. You can see the construction of the electric vehicle boxes which are on trials. So many onboard systems will be identical to diesel counterparts. What is similar and what is common? Some of the new systems are the electric heating and air conditioning, the electric accessories come like the power steering, the air compressors. And in electric drivetrain, the batteries, motors, controls, and the vehicle charging interface. What are the main challenges what we face here is the initial capital cost, because a new technology has to be born and the indigenization, identifying source across India, across the globe, how to market and how to bring in, how to assemble, how to work on it, the new operational requirements, the procurement handles, which part to source from which part of the world, charging interfaces, that is how to have a kind of charging, because we all talk about electric vehicles, hybrid vehicles, but where is the charging point in India? Because the government is right now working very hard to bring in or incorporating a lot of these kind of charging stations every 50 kilometers. So how about the long-term energy needs? So these are some of the batteries and the kind of units to measure what we use in our buses. So we are presenting the first zero-emission electric bus, which was made in India. The first electric bus was designed for tough on Indian emissions, and Pan-India service will be supporting us. It's actually made in the Made India concept, made for India, made in India, supported across India. We've got nearly 500 touch points across India right now. So there are two important technologies working on our electric vehicles. One is the Circuit F and another is the Circuit S. So the fast charging technology, the charging technology and the swapping technology. Some usually ask what is swapping technology, what is charging technology. So in this fast charging, the vehicle has to be parked and charged. Wherein you have to charge it for at least 2 to 2.5 hours and it runs for 50 kilometers. And every time you have to charge it. Whereas the swapping technology, we got collaborations with various other technology partners, wherein once you travel 150 kilometers, you can just swap the batteries at the swapping point, wherein you can just go park your vehicle there. The technology just swaps the battery with the used and the new one. And once it is done in 3 minutes of time, you can just move your vehicle to the next 150 or 40 kilometers. So that's how the swapping technology is going to gain confidence in everybody's mind. So these are some of the benefits. Very low noise, very less vibrations, zero emission. Performance is more, it works from 40 to 165 kilometers. As we talk about regeneration here, the maintenance is very less, and the driver's fatigue is also less. It's fast charging, within 3 years you can charge it. Some of the product specifications, what we are using in our electric buses. These are some of the buses which are on trials in various parts of India. And you can see the festival trials in Tirupati, Tirumala, hilly terrain with the fast charging technology. Our logo says Aapki Jeet, Hamari Jeet. In your victory lies our victory. So Ashok has been always in the people's mind, whatever product we're going to design, whatever service we're going to innovate. It mainly works on thoughtful innovation. What people want, because over 70 years this company is here only on people needs. Because many companies which are over 30, 40 years afterwards they go extinct because they don't understand customers. They don't really understand what people want. But here whenever we design a product, we make sure that we take the, because for this yellow bus what I was shown here is the kind of, this bus is called Sunshine Bus, wherein the children, small children are usable. So we took them by considering this bus, took their ideas, took the teachers, we just put parents input, and then we designed this bus. This bus has got a CCTV camera into the bus. Bus starts moving, the parent can sit at home, open the mobile app and see what is the kid, what is their kid doing in the bus. Because you know, there are two important incidents, three incidents in Chennai where the person, the children, what they were, the bus was traveling, they went underneath and the bus overran the child and into fatal incident. So this bus, of course, has kind of GPS tracking features. The bus has got anti-emergency seat covers. So a perfect example of thoughtful innovation. So before closing this presentation, let me show you the BMW i8 model, how it fares, because that's the most sought after hybrid vehicle across the world.
The intelligent plug-in hybrid, the new BMW i8, combines the best of both worlds in that it has a petrol engine and an electric motor. The first is a twin-power turbocharged three-cylinder sitting on the rear axle, delivering an output of 231 horsepower and 320 newton-meters of torque. And the latter is an electric motor that represents the latest addition to BMW's eDrive technology. The electric motor is sitting on the front axle, and centrally mounted between them is a powerful battery, all of which were specifically designed by BMW. This is how we ensure the highest quality standards, and it is, I think, the best response to the issue of practicality. Second, the BMW i8 is very dynamic. The battery I just mentioned creates a very low center of gravity. Riding a BMW i8 is a bit like driving on rails. And there's an all-wheel drive to add that extra margin to this kind of dynamic driving experience. When you're operating the combustion engine only, you have a rear-wheel drive. If you're driving all electric, it's a front-wheel drive. What's more, the BMW i8 boasts a combined maximum of 362 horsepower and a top speed of 250 kilometers an hour. Third, BMW i8 is very efficient. That's the beauty of the plug-in hybrid system. The electric motor takes the load off the combustion engine while it packs an extra punch. And the result is, it's the performance of a thoroughbred sports car with the fuel consumption of a compact car. It's only 2.5 liters per 100 kilometers. Now you might argue that the battery has only so much power and it's quickly drained. But not in full boost mode, the kinetic energy of the moving car recharges the battery. Or simpler put, the battery recharges while you drive your BMW i8. Even the energy when you hit the brakes, being recuperated. Back at home, to top up your battery, all you have to do is plug it into your BMW i wall box. If there's no wall box available, you may also plug it into a common wall.
So that we come to the end of this presentation. I thank QCFI chairman, QCFI GC members, and all the dignitaries from various parts of QCFI for having this kind of an opportunity to all the people, because lockdown is not that simple. It's very hard for all of us because we all are staying home. So how to learn? Because they made it Zoom kind of a learning. In the last 2 weeks, I've been part of various programs. It has been most welcome by many of the participants. Like kind of learning where we generally don't do at home. They have made us learn a lot of new things. So I thank on all your behalf QCFI for making this wonderful program for all of us here.
Yeah, thank you, Suresh. It was indeed a good presentation.
Thank you.
You started with the evolution of the vehicle and touched the modern technology, hybrid technology, how it works, not only on cars, not only on train, even on submarines and all sorts of vehicles. So really you have given a complete bird's view about what hybrid vehicles are, how it's going to be popular and how it is conventional, the difference from the IC engine vehicle, driven vehicle and the electric vehicle. So it's one of the good presentations.